Well, we got some power coming in. It's been raining all day, but we still got about 450 watts coming in. We got a little bit of wind, 200 watt hours so far. Not a whole lot, but it was a lot windier this morning. Going up to 50 watts, but... So, between the two, we've got almost 2 kilowatts in today, which is hardly anything. And what we got going on right now is we're charging these batteries right up. They are very cold. I'm going to bring out my phone actually. We're going to connect to the BMS and see what's going on, but it's only from here connected. This is a 24 volt pack, which I have to connect together with that other 24 volt pack. But right now it's just what is this, 4 kilowatts of power. That's 2 kilowatts and that's 2 kilowatts. And then we're going to do a discharge cycle. I'm going to use a watt meter and we're going to see how many kilowatts we get out. And yeah, see how that works and see how this BMS does. Get a good test going here. Maybe we'll run a 1500 watt heater or something. We got 14 amps going in. I might be cranking that up soon. Going to be getting some more solar panels soon for this system and the gels and the Chevy Volt batteries. I want to get 5 kilowatts worth. I got 4,500 on this system here, that there, so all these batteries, and even my my little Nissan Leaf power pack that's going in my trailer eventually. At least I believe it's going in my trailer. Who knows? I might just put the portable lithium 3.8 kilowatt battery pack in the trailer. I'm not sure, but yeah. Anyways, let's hook up the phone. As you can see, it's quite cold in here. It's only 1.4 Celsius, and I believe that because it feels really cold in here. We have 12 amps going in according to this. Let's look at my cells. Battery state. Here we go. It's my cell's voltage. Looks like I have one cell a little high there. Not really, but a little bit higher. And I'm going to crank up the current here. See how the system takes it. I think I'm going to turn it up to... So we've cranked it up to 32 amps. And the BMS is telling me 29.5 amps. Looks like it's warmed up ever so slightly. I don't know if that's just from me being in here, or maybe I touched the wire a little bit. Yeah, see what I just pushed the wire into the battery and it dropped. Let's see, here we go. That's probably what it was. I bumped it. It fluctuates like crazy depending on what you do with those little probes, so you got to get them mounted properly. Now look, it's bumped way up because it must have come way out again. But we are charging. Let's look at the individual cells again. Battery state. Go over. There we go. You can see all the cells and their balance. They all look pretty good, man. They're so close. Very impressive. And I'm not even using, on this BMS it has a battery negative, which you hook to your battery's negative, and then where you pull your negative from the BMS. So this is going to my inverter charger. I am actually charging through the P right now, where it says where you're pulling from, and then this is where you're supposed to charge from. I think it's optional because it did say that I could charge through this. I think it's set up for that, so we'll find out. I have the charge limited anyways on that to 4.2 volts per cell because they're so close anyways. And then this on top of it, I have limited to, I believe it was 4.1 volts per cell. So this should cut off, and if it doesn't cut off, that means I cannot charge through this side, which I'll be doing testing on. Let's go view parameters. Takes a little bit sometimes. Anyways, I'm gonna, oh, never mind, here we go. Here we go, overvolt state, 4.1 volts. So, pack over voltage 51 volts. So, looks pretty good. I'll go with this and see how this works out. I'm charging at a very high rate. Like, I'm really pulling some power out of my batteries. Oh, look at that. We're down to 61.6 volts. I think we're at 62 volts last time I showed you guys. But that is under sag on lines and whatnot, but still. I'm pulling. This is not the most efficient charger. It definitely loses quite a bit, I'd say. Oh, last time I checked it, it was like 85% efficient or something like that. It's not very efficient. I don't know if it's more efficient at certain amperages or what, but what I tested it at wasn't great. So we got a decent amount of power going in. Anyways, thanks for watching, guys. Hope you enjoyed the video. I'll give you an update soon. Alright, so we're testing if this BMS, if we're able to charge through the pull side. There's a pull side and a charge side. So that's power out, that's power in, and that's battery negative in. So I know that it can sense current going into the battery. So we're going to see. We're sitting at about 61 volts. I got this set to about 1400 watts to charge at. We will see. We're right at about fully charged. We're almost there. Sitting at 4.12 volts. This is slowly going to climb to about 27 amps. But we got to keep an eye on these. We're at 20 amps, 21, 22. As you can see, 23, 4. One's at 27. Oh, look at that, even 28. So 28 should be its max. And so I have this set to 4.1 volts per cell. And obviously that's over that. So if we go dashboard, what's it say? Oh no, overvolt. It's at 100% and we're still charging it. It's saying bad. So, what does that mean? It means it does not cut off on the pull side. Good thing I had that overvolt thing set to 4.1 volts, because when I saw it, came in here and disconnected the charger. It's nice. I literally, my computer's on the other side of the wall. I can sit right there and see all this. It's really nice. So, I'm going to go till one of these hits 4.2 again, which is going to be very soon. And that's more or less fully charged. It's more fully charged than I'm ever going to actually push this. This is through losses in the lines. It's saying 51.2 volts, but it's not. At the battery, we're less than 4.2 volts each. That one looks like it's going to hit the soonest. Right there. So I have to keep an eye on that one. That one seems like it charges a tiny bit quicker than the other one. So I gotta watch that one. See, it's about to hit 4.2. Maybe not. Maybe it'll balance. Sorry, I had it wrapped around my neck when I moved it. There's no balance lights on yet, so I do have it on 0.0. Oh, what did I have it on difference? Anyways, I'm gonna shut it down with my breaker. Okay, charger is now off. These are my cells. Okay, now what we're gonna do is we're going to see, it's still saying overvolt 100%. We're gonna hook this camera up. We're gonna shoot it at these two monitors, so you can see what the BMS is saying. You can see what the magnetic sine wave is saying, and we're gonna run a 1500 watt heater off this 4 kilowatt system inside my house. should be no problem for this system. 1500 watts should be no problem. As long as I don't blow my fuse. I gotta do the math, but I don't think I will blow my fuse at 1500 watts. I think that'll be like 30 or 40 amps, something like that. But yeah, we're gonna see what kind of capacity we get out of this battery. I have it set to cut off at I think it was, the inverter will shut off at 38.8 volts, and these will this is set to shut off at 3.1 volts per cell, I believe. So I'm pretty sure the inverter is going to kick out before the BMS does, actually. So that's good. And yeah, I'll get back to you guys. So we got everything all hooked up. Got my extension cord running inside my house, which is going to a 1500 watt inverter. And we're going to turn the inverter on so I can plug it's a digital heater inside. But when I turn the inverter on, you'll see everything happen on this camera. And yeah, hope you guys enjoy this discharge test of the Chevy Volt battery, 4 kilowatts worth of a Chevy Volt battery. So now we're discharging at 1450 watts. Let's see what we can see here. Function. 121 volts. And so we can see the wattage there. Now I'm going to go to kilowatts because I want to see how many kilowatts we have used so far. There it is, counting up right there. I hope that's catching. Yeah, I think that's catching up on the GoPro. Saying minus 30.4, and this is saying minus 29. So it's not perfect, but I mean, it's not bad. It's definitely not bad for a budget. Actually, this is showing up. Yep, a budget BMS, and it's not even that much of a budget compared to most. Like, those are real budget. These ones are 20 bucks each. They work great. Love them. They got lights they show when they're bouncing. This one has lights when they're bouncing, and it shows up on your device, whatever you're using. So the count begins. See how long this lasts. See if this BMS gets warm. Wonder if two devices can connect wirelessly like that at the same time. That's another test. Anyways, thanks for watching, guys. So, after some time of running this load, looks like 30 minutes and 30 seconds, we're at almost a kilowatt, 0.72 of a kilowatt, and we are sitting at, let's see if we can zoom in here, 83%, according to that. Still have the same load coming out, and sitting at 46.35 volts. Everything's working well. BMS is cold. Cold to the touch. Not even close to warm. Battery cables are all nice and cool. Everything's nice and cool. Cheapo. Well, it's actually, this isn't even that cheap. This is like $7 or $8 for this 60 amp. But it does have a warm spot. Warmer than the rest. I feel as though the way it crimps this fuse in is not good enough. So I don't know if it's just this one. I'm going to test it, and if I need to, I will replace it. I blew a fuse in here as well, and I'm wondering if that may have damaged it. I'm not sure, but we'll check that out later. But it seems to be fine for now. It's like just barely warmer than everything else. So anyways, looks like we're going to be here for a while with a 1500 watt heater. Probably another hour and a half before it goes dead. 2 hours. Something like that. But we'll give a little quick update on this whole system. These batteries are working flawlessly. BMSs are working flawlessly. 8,000 watt inverter working amazing. It was just running the central vac plus everything I had in the house. Well, not everything in the house. This runs everything in my living room and everything in my garage at the moment. I'm in the process of making it so between this is going to run my entire house, and then this is going to be, so this battery bank is going to be my disposable power, and then this is going to be my essentials running off the gel bank, and this bank with a rotatable switch. Still need to do my review on these batteries. They are a really nice battery. I do like these a lot. I'm going to do the same type of discharge test I'm doing here, but with a 200 watt heater. See what kind of output we have. I can already tell you I've done one discharge with it, just running my laptop and such, and I got 550 watt hours out of these three, and that's only taking them down to like 3.3 volts, 3.34 volts, something like that. Nissan Leaf batteries working amazing. Still doing a great job with this same BMS as all the rest. Doing really good. Looks like we've got zero solar coming in now at 2.2 kilowatts. Came in today. It was a really dark day. Really dark and gloomy. What else? Everything just seems to be working so good. But I'm thinking about doing a giveaway soon. And it's gonna involve, oh boy, this thing's heavy. This I have not used in a long time. This is an SWI power inverter. This is one that I repaired. It still puts out about 1500 watts. It doesn't put out its full power anymore. Might do a bit more than 1500 watts. I have not load tested it much. This inverter outputs 50 hertz, not 60 hertz. But as I did some research actually, and almost everything we have will also run off of 50 hertz. You got to check before you try and run it. Like most TVs, pretty much everything. If it's got like a transformer, it'll work off it pretty much for sure. But let me know if you guys think it's a good idea. It's 60 volts, 60 volt input, 120 volt output, 3000 watts. Anyways, thanks for watching. Well, my tests after about an hour, it's sitting at 55% is what my BMS is telling me. And look at that. guess this is not a continuous rating fuse. What a piece of garbage. Probably return the other two that I got and order some better ones. I was wondering what happened, but power just quit all of a sudden, and then fuse blown. Anyways, I'm gonna put another fuse in for now, and then I'm going to, because tomorrow is supposed to be really sunny, I'm gonna hook this thing back up for charging. Anyways, thanks for watching, guys. At the half an hour point, we made what was it, 0.7 something of a kilowatt. Actually, I think I'm still recording. There we go. And then at the about 35-40 minutes later, so I'm sure it made at least another 800 plus kilowatt hours. So it's too bad this doesn't have like a battery function or something. Actually, what about my log? Let's see what the log says. Let's see. Here we go. Highest voltage, lowest voltage was not too bad. Temperature of the batteries went up to 9.7 Celsius. And then, let's see here. Well, that just shows after discharge. So there's our cell over volt. It's very interesting. Okay, wonder if there's anything else that'll tell us anything. Come on. What's going on? You frozen phone? There we go. Battery state. How about the balance of our cells? Not doing too bad, actually. Not bad at all. I'm okay with this. Anyways, it looks like I won't be able to finish my testing today, but we'll continue this another time. So I put a new fuse in, and we're sitting at 45.2 volts. It looks like we would have got a lot more life out of it. This is black because every time I pop it together, it makes a big spark, and it's really dirtying this glass. Just gotta clean it with my finger or something after, but looks like there's a lot of life in these batteries, man. 1500 watt heater for an hour. So it's 1.5 kilowatts. So obviously there is a lot of juice left because it is a 4 kilowatt pack. But it looks like there's most likely 4 kilowatts usable, which is very impressive. Even if it went down another 1.5 kilowatts and shut down, that's still 3 kilowatts usable through an inverter. So plus 10% on top of that. Whatever losses you have, and plus the fact that they're almost fully charged, but they weren't, and I'm not discharging them to rock bottom either, so not bad. I think I got a nice good pack, just like the rest of these packs. These are all good. I've only had one of these car batteries come. Where is it? It's one of these ones here. Yeah, here it is. So one of these car batteries, so 9 of these modules per Hyundai Sonata electric hybrid comes in one car, and the BMS side was just fried. Like this one, the BMS board got hot, or maybe got hot from the other battery beside it. Doesn't seem to be destroyed. I'm not going to use it in my Powerwall, but I might use it for something else. But there's 9 of them like that. So I probably won't use those, but I have still a ton more there. Got 3 more Hyundai Sonata batteries there. So yeah, gotta continue hooking all these up with their BMS boards. Obviously this BMS board can handle a lot more than the 60 amp fuse. Stinking blue on 30 amps unless something happened and it started pulling more power for some reason. I don't know. Anyways, thanks for watching, guys. Hope you enjoyed the video. Hit the like button, helps a lot.